Hello everyone, so welcome back to my channel. So for this video, I will cover a brand new session. So it's called the inequality session. So in this video, I attempt to show you the review of this session. So what are you going to learn in this chapter? So you're going to learn how to graph inequalities and how you can solve inequalities in different functions, like quadratic functions will be the focus on this chapter. So the first thing you're going to know is to know what's the possible values for the x below. So we have two inequalities here, x less than 3, x greater or equals to 5. So I want to know what's the possible value for each x value. So first, x less than 3, we know that x could be equals to 2, right? So x could be equals to 1, x could be equals to 0, so basically these are all the possible value for x, which is less than 3. So but the question is x equals to 3 as well? So because I don't see the equal sign here, so I don't expect to see x is equal to 3. So x less than 3, the possible value will have 2, 1, 0, and the list goes up and extends to negative values. What about x greater or equal to 5? So we know that x could be equal to 6, right? 7, 8, 9, something like that. So my question is if x equals to 5 as well. So you will see that we have the equal sign, right? We have an equal sign below the arrow. So the equal sign signals that I need to include the 5 as well. If I don't have the equal sign, I don't include the number. So basically, x greater or equal to 5, we have 5, 6, 7, 8. So these are my possible numbers for x. So next, I'll show you the number line below the two inequalities here. So basically, I want to illustrate how these inequalities are illustrated in a number line. So let's see. So first thing I want to do is to pinpoint where's the location of 3 and 5. 3 and 5 approximately at this location. So how could I draw x less than 3? So basically I need to first draw the vertical line here and I draw the circle. So the reason why I draw the circle here because x is not equal to 3. So and I extend the line to this position. So this is what x less than 3 function looks like when illustrated in a number line. So what about x greater or equals to 5? So how can I illustrate it in a number line? So first I draw the vertical line here and I fill out the circle, so which means that x is equal to 5, and I extend the line to the right side, so which means that x is greater and equals to 5 for every x value. So in the previous math courses, you learned how to solve equations with inequalities. So basically in this video, I just want to go over the procedures. Okay, so how equations with inequalities are different from equations in general. So the first thing, we have equal sign when we deal with equations in general, but with inequalities, we don't expect to see equal sign. So it's really rare situations. So usually we have less than or greater than symbols here. So when we solve the equation solve for x, I just need to move all the numbers into the other side. So we have 5 plus 3 at this example. So we have 8 equals to 4x. So when I divided by 4 by both sides, I got x equals to 2. So this is what we usually do. So what about equations with inequalities? So basically we are using the same procedure as previous method. So we are first moving the negative 3 to the other side. So we have 4x in the left side and 8 in the right side. So if I divide by 4 by both sides, I got x in the left side and 2 in the right side. So basically in this example, I can copy the symbols here and put it here. So basically the final answer, we have x less than 2. But please pay attention that the sign is not always identical to the previous question. So yx minus 2 is the answers for the question. So basically, if x minus 2, the possible value will have 1, 0, -1, -2. So these are all the possible values for x less than 2. If I plug in these numbers into x, we will find that these expressions are less than 5. So that's why x minus 2 is the answers for the x. Okay, so let's look at different situations here. So we have negative 4x minus 3 equals to 5. So at the same time, I move the negative 3 to the other side. So we have negative 4x equals to 8 and x equals to negative 2. So if we solve for inequalities, equation is the same procedures. So I move the negative 3 to the other side. So we have negative 4x in the left side and 8 in the right side. If I divide it by negative 4, by both sides, I got x in the left side and negative 2 in the right side. So x should be less than negative 2 at this example. So is this correct or not? So I want you guys to think about this. So let's list other possible numbers for this one. So we have x less than negative 2. So we have all negative 3, negative 4, negative 5 are all the possible values for this one. Is it true? So if I plug in negative 5 for this equation, we have negative 4 times negative 5 minus 3. So which is 20 minus 3, which gives us 17. So 17, is it less than 5 or not? So it's not, right? So if I want to be this one smaller than 5, so these must be negative values. So if I want to make this negative, I need to make the x at least become positive. So that's why I need to shift the sign for this one. And I cannot say x is less than negative 2. I need to say x is greater than negative 2. So the sign switches at this example. So make sure you list out your possible values and verify your answers when you're solving for equations with inequalities. So thank you for watching this video.